All right, a continuation of the first day. And one thing I really want to make a point of that I don't think I did a very good job of explaining in the first set of notes is how you get these class, they're not really the boundaries, but the class marks, like the front and end. For example, we found out that the class size on this one from the previous day was 12, right? Because we had to round up the 11.6 or whatever it was, so we went up to the most convenient next number, right? So then why is it that our first number here, because that's the lowest number that happened, was 7, right? So then why is it that I ended at 18? Because if I take 18 minus 7, that's 11. Why is it that we actually go 7 to 18? And I really did not do a very good job of explaining that, I don't think. Okay? Because if you think about it, when you subtract 18 minus 7, you're throwing 7 out, right? Where I actually want 7 to be a possibility, right? So if we actually listed all the possibilities that would fit into this class, I would put 7 in there, right? And I would put 8, I would put 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18 would all go in there if any of those happened, correct? And how many possibilities are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so did we actually make it the right size? We did. Okay, but I could see that if I set you off on your own right now and didn't explain that, you would do it wrong, and then when you saw the answer key, you would get very frustrated because it's such a small little thing, and then you just all comes out wrong because you made that simple mistake. So really, a lot of times, what I tell people to do is, okay, if it is actually 12, actually just add 11 to it, and it'll get you to where you want to go. Okay, does that make sense with the whole subtraction thing, that you're kind of throwing 7 out when you do that, when 7 really should still be one of the options? Okay, so be very careful with that, please, because these tables are actually going to get rather wide when we're finally done doing all our calculations, and if you mess up right at the beginning, it's going to be incredibly frustrating after doing all of that work, because you basically have to start over. There's no way of just going in there and fixing it easily, because everything after that will be wrong. Okay. Were there any questions? I believe the first recording got to the relative frequency and cumulative frequency, right? And then it stopped. Right? That's all the further it went. Okay. Hopefully there's no questions on those. Midpoints will prove, the ones in green here will prove very helpful once we start actually making some of these graphs, because it's less to write if we use those. And always check, make sure your cumulative frequency, the very last one, is actually your sample size, right? Because we are adding them all up. And my sample size was actually 50 people, right? And so that makes sense that it ended at 50. And the relative frequency, again, is kind of just the percent of the data that fell into that class. So 12%, 20%, 26%, so forth and so on. Okay? Any questions? All right. So here we go. Let's go to these definitions that didn't quite make it on the first day, because I think we were running out of time when I did that recording. So earlier we talked about frequency distribution. That's just what you showed me. You showed me how the data was distributed throughout those classes, correct? Now a histogram is going to be more of a display of that data. And a lot of times a histogram is going to be a bar graph of that data. And basically that's what this is going to tell you. It's a bar graph that represents basically what your frequency distribution is telling you. But it's much more of a visual representation of it. Instead of just what you saw on that previous page, it's going to be a nice little bar graph. And you do have some options with a frequency histogram. And once we get to the day 2 page of notes, that'll show you those differences in how you can display that. Class boundaries. Well, if I remember correctly from the previous page, and you can draw this off to the side or just watch up here, we basically had, what, 7 to 18 was one of our spots, right? And we had about 6, so let's say it would look something like that. That's 6, we'll say, okay? The next one was, what, 19 to 30, right? And we had, well, how many of those did we have? We have more, right? So it would look something like that. How come my bars aren't touching when I made that? Because I strictly went from the information on the other page, right? How come my bars aren't touching? Well, what would you do with 18 and a half? Does that really fit into any of the classes that we made? No. Did it really matter what the example we used? No, because 18 and a half didn't happen. But is that something that could happen in other problems? Easily, right? So what we do is we make class boundaries, is what they're called, because we would really like these bars to touch. And the easiest way to make these bars touch is basically from each way, go out an extra half, because then they will touch, right? Because then I would go from 6 and a half to 18 and a half, right? and then 18 and a half to 30 and a half. Okay? And then if I actually drew the bars in, they would actually touch. Okay? Because we would prefer to not have gaps in there. And that's really what class boundaries, hopefully I don't have to erase too much of this. Well, I do. Or maybe I can just move this quickly. Ooh. Uh-oh. Oh boy. This is not going well. Hopefully it grabs it. Whoa. Yeah, you know what? I'm just going to leave it there. And move this up. The number that separates classes without forming gaps between them. Okay, and the easiest way to do that is to just kind of go a half each way. And we are going to have to talk about class boundaries because some of the pictures we're going to take a look at use the class boundaries. So we are going to have to take a look at that. Is everybody okay for me to erase that picture there? It's not very artistic anyway, so it's not exactly all that good. Well, we just talked about a frequency histogram up at the top. It's a bar graph that shows the frequency distribution. Well, a relative frequency histogram is going to be a bar graph that shows the relative frequencies. That's all it's going to be. Again, relative frequency is the percent of the data that fell into that class. Like our first one on here was 12%, followed by 20%, so forth and so on. Would anybody like to try and pronounce that last word? It actually has two names, but I don't give you the second name because I want you to try and pronounce this one. You want to try? It won't actually get up in the recording unless I repeat what you say. I'll give you that's what it looks like, right? But it's actually ogive. Ogive. So it's just kind of weird, right? Yep. Yeah, it looks like ogive though, right? Doesn't it? Ogive. What that is, well, let's face it, what's the one thing we haven't really displayed yet? That's the cumulative frequency. Whoa, hit the wrong button. So again, it's really could be called the cumulative frequency graph. It's normally a line graph though that will display the cumulative frequency of the classes as you go. And when you do that, you use the upper class boundary. So now you can see why I had to talk about class boundaries up there, because we're going to use them to graph the ogive. Okay? It's kind of like a particular student's last name that has a D followed by a Z and it makes the J sound. I don't want to say that name, but you can probably figure out who that is. But it is Polish, so I guess they just make it whatever they want. All right. So those are our options. And yeah, and definition's great, but I think a lot of us are visual learners, and so we're going to take that's what that second page is for. We're going to take a look at those and try and figure out, of these that we have here, is it a frequency histogram? Is it a relative frequency histogram? Or is it an ogive? Yeah, I just like to say that one. It's this one. Okay. And then we'll see if you make any discoveries when we look at them. Because on your other sheet that you have, that once I turn the page here, you're going to see, actually is a display of your example that we have. It's a lot of different displays of it, right? But it is all of the example that we've done. Okay. Yeah, there was a typo there, yeah. It's a bar. For a relative frequency histogram, it should be a bar that represents. Sorry about that. Sometimes I get typing a little fast. Yeah. And of course, spell check's not going to catch that because I didn't spell anything wrong. And grammar-wise, it's not really wrong either. It just doesn't sound right. What's that? No, oh, good, great question. It did not know ogive. I had to basically take the red underlining off of that because it really didn't understand what that was. Yeah, exactly. Yeah, add to dictionary. Exactly. Okay. And I can always come back to this page for you. Okay. Right. So let's take a look at these first ones here. So which one is it? Is it a frequency histogram, relative frequency histogram, or the cumulative frequency histogram, or again the OJI? So let's take a look. Let's take a look at the bottom. Notice we have what, 12 and a half on our axis here, 24 and a half, 36 and a half. So you notice that's where the midpoints come in, right? You can actually use the midpoints of your classes down at the bottom if you'd like. If you looked at your other sheet of paper, you notice those are actually the midpoints along the bottom. And then along the vertical axis, we have a 2, a 4, a 6, and then normally above the bar or in the bar. So like this, what I mean here, you can see the 6 here. Sometimes they just put it right in the bar, right? So you can see it. Okay, a lot of times they'll do that so that there's no misinterpretation of the data. Okay, and so we see all of them there. Well, what is the 6, the 10, the 13, the 8, the 5, the 6, and the 2 as we go along? Those are actually the frequencies in that class, correct? But now what we have to do is look at the vertical. Well, that's actually just the frequency, isn't it? So this is, what do you believe this one is? Of those options, is it a frequency histogram, relative frequency histogram, or the cumulative? Well, remember, cumulative is supposed to be a line graph, so that's kind of out. It's got to be one of the bar graphs. So it's one of the first two, frequency or relative frequency. It is just the frequency. Very good. It's how often these particular things happen. So this one right here is a relative. Oh, no, just excuse me, a frequency. I started reading the word over there. This is just the frequency histogram. If you take a look at the one on the right, same information. But notice now at the bottom they use the class boundaries. You see that? How they're using the class boundaries so that the bars touch. Okay, that way there's no gap between the bars. But then what does this vertical axis? Those are decimals. Agreed? Normally when they're decimals, you're not going to get the value on it. What do these decimals represent over here? A portion out of 100, basically, correct? So this is what type of graph? This is a relative frequency. Very good. Relative to the rest of the data, this is what? Relative frequency, and it is a histogram, because it is that bar graph. One point I'd like to make is this particular horizontal axis, that is your choice. These two could have been flip-flopped and it would not have changed our answers to them. This one on the left still would have been a frequency histogram. That one on the right still would have been relative frequency. Some people like to use midpoints because, let's face it, it's less writing. Agreed? And then some people like to use the boundaries like we did on the right side here because they like to have it set up so they can see it. Either way, back and forth is fine. So really what was important was the vertical axis. Was very helpful to us, correct? What information was I given? Okay. Do you notice anything about the two graphs themselves? Don't look at the labels at all. Just look at the actual shape of them. They're identical. Okay. They should be though, shouldn't they? All you're doing is you're giving the information differently. Are you giving the relative like we are over here, or are you just giving the counts? And if you think about it, if you space them out equally, it should look the same. Okay, any questions on those two? Okay. Does anybody believe they know the answer to any of these three? I will warn you, there is a trick in there. One of them is not any of them that we've talked about yet. I'm very mean. Okay. The bar graph is frequency, which type? Relative or just frequency? Do we agree on frequency histogram for the bar one? Yep. So why is this different from the other one? All they did, you notice, is they used the boundaries, right? I told you could do that, right? It all depends on your personal preference there, but this one's kind of set depending on the data. So this is definitely just a frequency histogram. And again, it should look very similar to that first one, right? Okay, so we're down to the two line graphs. Okay, so we know that it's probably not a histogram because histograms are bar graphs. Okay, normally. So we've got this one at the bottom or this one at the top. Any thoughts? Yes. Okay. Yep. 8. So 5. Yep. Okay. Very good. So you're saying that this graph over here really is following the same pattern of that graph. It's just not in a bar. Agreed? Hmm. So we haven't given one answer yet. We haven't given ogive yet. I will tell you one of these two is the ogive. Which one up? The ogive remains cumulative. So you have to look at that cumulative column. Which one's cumulative? Yeah. Exactly. Here's your ogive. Very good. What was just said is if it keeps adding up as you go along, well, this one makes sense. It keeps adding them up. Now, the one thing that you wrote down in your note for ogive is that you use the upper class boundary. So here's 18 and a half, and that's where they graphed the 6. Notice here at the 6.5, which would have been your very first class boundary, they put 0. See that? And then they used the next class boundary and kept going. That's how you normally do the ogive, is you use the upper class boundary, whatever that is, and you graph it for that. Because your first one was what, 7 to 18 was the actual class, right? And 6.5 to 18.5 were the boundaries then. Notice how they used 18.5 to graph the 6. You with me on that? And then they used the 30.5 to graph the next one, and so forth and so on. Okay? So that is your ogive. So this one we don't know, but this actually is a graph that you can have. This is actually called, well, what is graphing? What is it graphing here? Is this cumulative or not? No, it's not cumulative. Those are just the what? Those are just the, if we look over here, those are just frequencies, correct? See, this is actually called a frequency polygon because you will always connect it back to that horizontal axis. So then does it kind of look like a polygon when you're done? It will if you always connect it back. And notice they kind of started at the 6.5 here, and they ended at the 96.5. So they went from the very beginning to the very end, and they closed it off. Okay? So that's a very helpful way to tell the difference between a frequency polygon and the ogive. The ogive is probably going to keep going up, right? It might level off if you have a class of 0, right? But it should keep adding up, where the polygon is going to be all over the place. Okay? So do you have any questions on the different types of displays that we have so far? Okay, there is actually one more, but I'm going to worry about that later. I think we have enough for right now, right? Especially with that weird new word. Okay. So are you clear on the difference between a frequency distribution and a frequency histogram? The distribution is that table you make that shows where the classes are, how many went in there, and all of that stuff. That's the big table. Once you take that table and put it to a type of graph, some of your options are the histogram, the frequency histogram, relative frequency histogram, or possibly the frequency polygon or the ogive. That's your visual display of the data versus the actual distribution, which is in your table. Okay, everybody good with the difference there? Yes, we're not, well, I'm going to see what you do. I'm going to give you just 1 or 2 on your homework for tonight to see how you can make the table or make the graph. Yeah, I will help you out with that. I don't think I ask you, I do ask you to do a couple on your homework tonight. I want to see what you come up with, and then if we need to adjust, we will. But the key is making the table right. You have to go slow and make the table right, because let's face it, if you make that wrong, you're going to graph it wrong, and then you're going to get frustrated. Okay, because you did all that work, and you have to pretty much start over. Okay. Okay. Any other questions? All right.